All right. So, it says we're live and things look online. Okay, not sure why the YouTube preview doesn't actually show me my video, which is a bit unusual. Okay, now it does. Took a little while. Okay, hey, it's been a little while, mostly because of travel, Incus release and everything, but now I'm back home and gonna get back to some of those weekly live streams. So, as usual, I'm just gonna go through kind of what happened since the last one of those. And I don't think the list, even though it's been almost a month, I don't think the list is gonna be too long, simply because of, again, travel and time off and whatnot. So, last time we were looking at building the image customizer. So effectively, like a REST API service to download a prepackaged, like a effectively a prepackaged ISO or raw disk image that includes the seed data to install Incus OS. And I got reasonably far, I think, in that live stream. I effectively got the all of the network transfer, compression, all that kind of stuff going, and then completed that work bit like over the few days after that. So if we go all the way back then, so that landed, like some of it landed around here. That was the UI for it. I don't remember if I upstreamed the server separately because I seem to recall multipath stuff having happened afterwards. So I'm just kind of trying to refresh my mind. It was 2 weeks ago, and that last live stream was more than 2 weeks ago, I'm reasonably sure. When would that have been? Because it wasn't last week, that's for sure. That was a Incus release week. So the week before that, I was traveling and coming back on that day, so it wouldn't have been then. It wouldn't have been the 17th either, because I was also traveling. So it would have been all the way back on the 10th, I think, is the last live stream. So that's quite a bit further than this, so I still need to keep going. Let's see. Okay, there we go. It says last month. When is that? 9th. Okay, so right around then. A bit of cleanup. Still on the 9th. Production key that had been done. Then there we go. Okay. And initial image customizer is there. There we go. That makes sense. Cool. Okay, so that's where we left things off. After that, other changes that came into Incus OS since was the addition of so this one, like the injecting of the DER keys. That's to make it easy to enroll the secure boot keys on production servers. So that's been added. That's very convenient. I use that almost every day when installing IncusOS on production servers. We bumped initRD timeout significantly more. That's because when you install on servers on the other side of the planet using virtual disk redirection, you cannot need that. Otherwise, reading from the CD-ROM drive is so freaking slow that actually feeding, well, effectively the system just times out. It's reading stuff so slowly that it thinks something is wrong and just times out. So we initially bumped it to, I think, 3 minutes from 1:30, and now we had to bump it all the way to 10 to actually get things working pretty well on those kind of environments. But anyone installing locally, it's gonna take 5 seconds instead of 10 minutes, so not a problem to have to bump that a bit. Okay, what was that one? Okay, I think there's like a whole bunch of cleanup for a new version of the static analysis tool that we're running. So those were just to make the static analysis tool happy, just cleaning up the code. Then we had some servers not booting IncusOS due to missing support for one of the common LSI RAID controllers. So we've added that in the base image. So the Mega RAID SAS kernel module is now part of the base build. Then some cleanup around downloading images. And that was so that was the work to get the Flasher tool to use the new image server instead of GitHub. So Matthias did that 2 weeks ago. And then what did we do? So that was getting the Flasher tool working with the new image server. Then so check to ensure. Okay, so that's just kind of a sorted cleanup. So yeah, making sure that our state struct has the correct version number in it. A few more checks to make sure that we're not installing on a media that's too small. That was causing some issues with people trying it in VMs. So now there's a proper check and an error that tells you that. A few cleanups in the API. Tweaking, there was a bug in the text UI when it was managing multiple actions at the same time. It wouldn't properly clean the screen. So that's been fixed. A bit more cleanup. Trying to properly blank the different consoles. So we still have some issues with that, but yeah, some tweaking on the console handling. Then cleanup of systemd units a bit. And then I added proper multipath support through an actual service. So that lets you enable multipath and then configure multiple disks, or configure disks that are using multiple paths. This is mostly if you're doing Incus OS on top of fiber channel storage arrays. So it might affect some people in production, but it's somewhat uncommon for everyone else. But if you do, now you can turn on multipath, tell us which WWNs, so effectively driver global identifiers, should be using multipath, and then we'll configure multipath D and actually show some details on the topology as well. So that's been added. Then support for the Operation Center was tweaked so that it can support a self-signed certificate, so you can specify it in the seed now. The image customizer, then a bit of work was done to actually land a initial UI. I'll show that just afterwards for anyone who's not seen it yet. And then a few more tweaks on handling of the target that's still in the UI. What do we have? We did some tweaks to UDEV to try and make it so you can reinstall systems. I've not had super good luck with that new logic, but should still be better than what we used to have. Basically trying to make it so if you boot the install media and you have an existing IncusOS install on disk, it doesn't get confused and just refuses to boot or just hangs. It should effectively let you go back into the installer and reinstall the machine. As I said, I've not really had super good success with that, but there's upcoming changes to systemd and UDEV that should make that a lot more reliable. Then that was a small fix to the UI because I messed up something in the web page. Tweaks to handle the required for online flag on interfaces. So effectively, the issue we had is that if a system had 6 network cards on the default network config and only like one of them was working, we would just fail and try all 5 others. Whereas what we actually need when coming up with a default config is basically if any of them gives us connectivity, we're happy, and then fix it later. So we've tweaked the logic a tiny bit there. Then we had some issues with the naming of the network interfaces, so that's been all tweaked now, so that the names in the files are exactly what you get on the system, and any internal interface we create is effectively hidden away. So that's a bit more cleanup we did, and are we at the end? I think we're at the end. Yeah, we've got some other stuff ongoing, specifically the storage API that's been kind of ongoing for a week or so now. Trying to get an API that lets us create additional storage pools with extra disks on the machines, do a bunch of tweaking on like what kind of replication we want, support for caching and all that kind of stuff. So that's a pretty big piece of work that's currently landing. I said I would show the customizer, so the UI for IncusOS download. So that's what it looks like right now. Just a basic web page. Everything, including the web page, is all available in the IncusOS repo. So you get to pick whether you want an ISO or USB media, if you want to have it installed or not. That's not really an option if you're using ISO. If you're using ISO, you effectively need to do install only. Then you can choose whether you want to wipe the disk, if you want to automatically reboot. You can put a pattern for saying I only want to install on, I don't know, NVMe, Samsung something, and then it will only select those drives. whether you want to apply the default config for Incus, and then you can provide the Incus certificate that needs to be trusted post deployment. So it just makes it easier to download an ISO that's already good to go. Basically, it does the same job as the Flasher tool, but then you don't need to actually run the Flasher tool. You can just do it on a website, click go, and download the ISO. All right. So that's basically where we stand. And as you've probably gathered from the title of this live stream, my current, what I would like to explore now is whether we can build Incus OS for other architectures, specifically ARM64. There's going to be a bunch of restrictions and annoyances, I think, for a lot of people who might be very enthusiastic about this effort, is that we still want the same security characteristics. So we're likely to still do UEFI secure boot TPM on ARM64. That will eliminate basically any consumer grade platforms. You won't be able to run it on Raspberry Pi, you won't be able to run it on any of those kind of things. You're gonna need an actual ARM64 server, something like an Ampere Ultra or those kind of chips, to actually get an environment that has UEFI secure boot with a TPM. That said, there's some workaround for that. I'm running my Raspberry Pi 4s with a UEFI firmware here. So I do have secure boot support on my Raspberry Pi 4s. I don't have a TPM yet. I've seen that there's like some hats that add TPM support, but I don't know if the UEFI firmware supports it. So there's a bit of work to be done around that. It's not completely impossible that we will be able to support a few consumer grade platforms when they run in UEFI plus TPM mode. But that's going to involve most likely extra hardware and some configuration and stuff to get it going on those kind of platforms. Our goal with IncusOS has always been to provide a very safe, modern platform. So as much as we understand that like a lot of people like to run Incus on like cheap embedded platforms, if they're not safe enough for us, we're just not gonna support them. Anyway, with that being said, let's look at building IncusOS on ARM. As I briefly touched on, I think in the chat earlier, I've not had much time to really prepare anything, so you're gonna have to watch me do it as I go. I think I can just do remote dev. That should get me into my dev cluster here at home. Let me just change the zoom level a bit. There we go. That's got a bunch of containers and VMs and stuff. And in this case, I'm gonna want a new VM. So we want Debian 13. Let's call that IncusOS build. I want that as a VM. Actually, let's specify that we want. It's ARM64, I think. Yeah. Specify the architecture, and then we want 4 CPUs and 8 gigs of RAM, I guess, should be enough, and a root disk size of what we do, 50 gigs, and probably also put the root disk on the local storage pool. I think that should be it. Let's try it out. Okay. So the ARM server this is going to be running on is one of those actual like proper ARM servers that's got UEFI, it's got a TPM, it's got all that kind of stuff. So obviously we're going to do everything in VMs today, but the idea of having IncusOS built for ARM is to eventually be able to reinstall that host, which is currently I think on Ubuntu 22.04, and reinstall that on top of IncusOS. So let's go in our VM. It should be booting up now. Okay, it's booted. So if you look at CPU info, we should see this is 4 CPU cores, ARM, running 612 kernel, ARM64. Cool. Let's install Git and then git clone the code base, then install. We'll need to install macOSI, and then just try a plain build. I expect it's gonna immediately fail, but we'll just start there and then kind of go from that point. My expectation is that there's a bunch of places where we're hard coding the architecture name, so that will need fixing. And even like once we get the image to actually build, then there's going to be a bunch more changes needed to the IncusOS process to also do different architectures and handle all that stuff. Because even simple things like the labels that are put on the different partitions, they change based on the architecture, so we need to change that. There's some weirdness, I think, also around Secure Boot that's slightly different. There's a whole bunch of things. It's not gonna be trivial, but if we can get at least a base image building today, that'd be cool. Even though we fully expect it to blow up whenever it actually starts up. All right, so we've got Git now. Let's just go and git clone the repo. Okay. I want to just look for pipx. There we go. Someone's saying like that if this supports both OS containers and VMs and has a web UI, it can replace Proxmox. Well, I mean, we have all of those, and yes, people have been using it to replace Proxmox in some scenarios. If you've never seen it before and you're just running Incus on a standalone box or something, actually you can just go on the website and look at it. So if you go on the Linux Containers website and you do Incus try it online, and then just say go and try, that gets you the CLI, which has examples for launching containers and launching VMs. But you can also do try the web UI, which normally works, but today does not, so that's great. Okay, what's going on? Incus is definitely running. I swear it was weird. Like we had some issues with tracking down of IP addresses in the past. But that's been fixed. I don't know why it's not loading. Okay, well, let me write down a note. I need to go and fix that now. Yes, almost certainly it doesn't have the IPv6 address on record for that instance, and so it can't find it, but I put a fix for that in place. Let me just... yeah. I'm just wondering if it's affecting all of them or I just got unlucky with that VM, so let's try another one. No. Yeah, okay. Let me write down a note. I need to fix that today because it's not good. Fix Incus UI in the new environment. Okay, so I do have that now on my to-do list for today, and I'll fix that just after the live stream. I actually wonder what happened because there was a bug in Incus demo server, which is the service we use behind this to find IP addresses. I had to bump the timeout a bunch to get an IP address. Oh, hold on, I bet I know what's going on. So this runs on Incus OS, which is why it's not a complete tangent to go look at it. I bet what's going on is the image. Like we pushed an update yesterday. I bet the image has not been rebuilt since. And so on first boot, it took so long due to it having to update itself that we never caught the IP address. I bet that's the issue. So might need to bump the timeout even higher to avoid that situation, to effectively deal with the case where there's an update. Let's see, so... okay, so that's where we pick up the IP address of the instance. That's where we retry every second, and there is now a 2 minutes timeout on it. Clearly 2 minutes not long enough when there's an update. I'm gonna go overboard with this one and just go with, we'll give it 10 minutes. It's gonna be way too long, but if what we're looking at is indeed an update happening, that's gonna fix that. Let's just go enable 0, go build. Actually, I don't think I built it. Yeah, I don't think I built it statically. Okay. All right, and just normally it's deployed through Ansible, but when I do those kind of hot fixes, I can just push it directly. Yes, it's a directory, I know. Okay. I don't like this kind of stuff being broken. That just reflects poorly on the project, basically. So I'm just gonna go, yeah, here. And then restart it. And when it gets restarted, it, I don't have, no, okay. When it gets restarted, it effectively regenerates, like prepares a already cleaned up batch of instances. So it must be doing that now. Yeah, that's the correct cluster, and project is, try it. So if we look here, we're seeing all of the VMs currently running on the demo service. There's actually old base can go away. I forgot to delete that when I moved to Incus OS. That can go away. Okay. Huh. I actually see something kind of funny going on here. That doesn't look right. So that could also be the issue. Okay. So it might just not be just a timeout thing. It might be a we're getting an IP address on the wrong interface thing. Yeah, this is kind of confusing. Because this is the bridge that should have the IP config on it. And instead, we're getting all the IP config on its parent. So that's a bug. Okay, so that's the that's most likely the problem. Let me check. I can do a quick workaround for that, but because I bet when we're here, we look specifically there. Yeah, we look specifically for ENP 5S0, and if not, we just skip. So that's not exactly, that's never gonna pick up that address. That's a bug, to be clear, but that's what's causing this thing here. Okay, so let me just do one thing first, which is sending that to, whoops, wrong screen. I'm gonna send that dump to Matthias so that he can go look at that. Okay, so just send him that. So we'll fix that bug. Then the next thing is, okay, it's gonna be a bit of a hack. I think I'm gonna need to do for this one for now. Because the name can't really be predicted. So then if we go over the addresses, we skip if it's empty, we skip if it's not global. And then, okay. My good feeling is that I can remove this chunk here for now. And actually, I'm gonna put one caveat to that, which is basically if net name is Incus BR0, skip, because we definitely don't want to report that as our IP address. That'd be completely wrong. So we should skip that. But other than that, the rest should be fine. Because from what I've seen, so there's an IPv4, but we're gonna ignore that, I think, in our config. And then the only global v6, if we do show type global, scope global, yeah, the only global is, other than Incus BR0 is on the other interface, so that should fix it. Okay, kind of tempted to bring that down to just 5 minutes then at that point. And Incus BR0, skip, otherwise we're good. Okay, go build. Bit of an unexpected distraction, but it is still IncusOS related, so I'm not feeling too bad about spending a bit of time fixing that right now. Okay, where's my server here? Move the new binary, restart. And now we need to give it a tiny bit of time to effectively, it's cleaning up its previously built instances and starting, like we can see, this one is starting up right now. We can actually go and look at it a bit. So if we look VG output there. So it should actually start up. Yeah, here we go. Okay, and we'll see, maybe it's gonna have an update to apply. So see if I had that part right at all. Apparently not. So I guess it did update since we published the last update, because it just shows system is ready. So now that means this VM is ready in the pool to be used for new sessions. If I go here and I get a new session, we'll probably get actually that very VM, or maybe the one right afterwards, but okay, that's fine. Now do we have UI? Yes, there we go. Okay, so that's a workaround for now until we fix the logic in IncusOS and the IP actually shows up on the right thing. And at which point we'll be able to remove that hack. Excellent. So that's the IncusOS, that's the Incus UI anyways, which is kind of what I wanted to show initially. All right, back to doing ARM. I'm just seeing in the chat there was also, if we build an orchestration layer, it can take some work of Kubernetes, not all like scheduling big to image and containers. Yeah, so I mean, we support system containers, OCI containers, so like your normal kind of Docker style containers, and virtual machines on Incus. We've got support for Terraform, we've got support for Ansible. So there's quite a lot you can do. And if you're, it depends what you're doing with K8s. If you're using Kubernetes for what it's actually meant to be used for, so large scale, horizontally scaled, stateless service infrastructure, then no, we don't really do that because we don't do any of the auto scaling and that kind of stuff. But if you're only running a static, like a somewhat static set of containers, or even VMs with KubeVirt on top of Kubernetes, then yeah, Incus will handle all that just fine. All right, so distraction over. Let's go back here, and we were at installing the macOS sidebar command itself. Okay, apparently pipex doesn't come with pip. I have no idea, but is it its own command? Yeah, it's its own package. There we go. So I'm just gonna grab that and install. I should actually mark in my to-do list that I did fix the online demo issue. There we go. So just downloading what we need for make OSI here. Okay, I suspect we're gonna still be missing a bunch of stuff. I mean, the best is probably to go check actually what we're installing here. So we're installing bin utils and a bunch of other things. So we should probably get that one here. And just run us through that. Okay, well, that didn't work. Not sure why copy paste is so difficult. Okay. So basically installing the same dependencies we would get from within the our normal GitHub Actions build environment. And then we can try to do a basic build, which I expect will fail very quickly. And there's a command that K8 sucks at stateful sets. And yeah, I mean, with good reason. Like, K8 is really not designed for anything stateful. That wasn't really the intent for K8 from the beginning. and people trying to kind of force their way into it, whether it's, you know, KubeVirt running VMs on top of K8s, or it's other workloads just like running massive stateful containers on top of K8s. It's not really meant for that. It's really meant for, like, its strength is really around dynamic scaling, service mesh, service discovery, like horizontally scaled applications. And that's what it should be used for. If you're just gonna use K8s and throw, you know, 5, 10 fixed containers, never redeploy them, and they're just like all stateful and big things that you need to manage directly, yeah, don't use K8s. Like there's nothing wrong with, you know, using the right tool for the job. And we pretty often see folks running Incus clusters, and then if they do have newer newer applications that are designed around microservices, that are designed to be scalable and everything, then run a K8s cluster on top of your Incus cluster. Like you create a bunch of VMs, you run that as a K8s cluster. We even have a Kubernetes cluster API plugin these days that lets you dynamically spawn more VMs on Incus to accommodate the size of the K8s environment you're running. And that's I think how most folks should really be running their infrastructure. Like there is a difference between your long-running stateful stuff, whether it's legacy or even modern support infrastructure, and your like effectively stateless, I don't care, we can respawn everything in 5 minutes type of kind of workers that should be running on top of Kubernetes. All right, so we do have all the dependencies installed. Let's just try to run make, and that failed immediately because we don't have Go. Okay, how do we install that in the test runner actually? Well, I guess we just use, we use a setup go GitHub action. That's how. Because if I install what's in Debian, I think it might be a bit old. So I'm just gonna go and actually download it from the Golang website. Making sure to download it for the right architecture, because this is not x86. So we want Linux, ARM64, this one. And let's just go and handle that. So we want curl. That's already installed, convenient. Curl this guy and just it's not gzip. Oh, I forgot to follow the directions, that's why. There we go, that's better. I actually kind of messed that up. That's supposed to just go in user local directly. There we go. And then export. So just expand the path to include go bin there. Now we've got go and can make again. Go. So that's building Incus OSD, and then after that it goes on to make OSI and actually building the image. Like while that's going on, we can get an idea of just how broken things are gonna be. So if we go back in my environment here, Incus OS build. Okay, and we go in here. So now if we look for anything that mentions, say, AMD 64, okay, that might be a problem. That might be a problem. Those might be a problem. So that stuff's gonna fail. Now, other thing we can look for is x86 64, and we've got another few that might blow up. Like we don't care too much about the publisher or customizer right now. That's fine. This, I think I might actually have the different architectures, maybe. What do we have? Yeah, we already have both. So this one is good. So x86 64 is actually fine. AMD 64 is what we need to actually fix. And the list is not so bad, but I suspect that some more things are not being caught just there. This one failed already, and it failed because finished running. macOS could not be found. Okay, so that's just what does that get installed? .bin? No. Local bin. Okay. So I need to also add that to my path. Okay. Let's run that again. So we see the package at least is being built for ARM64, so that's good. It's an Arc all package at the exit, that gets generated anyway, so it doesn't matter too much. But just so in the package build package output that it did pick up the architecture correctly. That part of macOS seems to be doing the right thing, but like we're definitely gonna have to do some amount of file templating of some kind to fix those. Same thing with, which one is that? macOS images, Incus install. I mean, this one should have pretty easy access to the architecture. I actually wonder if we need to specify it right now. Huh. Like, I'm not sure if apt actually requires the architecture to be specified, or if it can just figure it out on its own. It would be very convenient if you could just figure it out. Let's see. So my VM here, I think it just has a legacy sources.list. Yeah, that's not really helpful. But if we are to effectively run this, so I'm just checking what it does. It just alters the system and tries to install the package. Okay, so I can actually run that, and if I pretend that I'm in final mode, it ran it against my own system. So it did manage. We see it's putting the wrong architecture here, AMD 64, and then it promptly blows up because it's the wrong architecture. So that makes sense. Now the question is, if I just remove that and I update, what do we get? Yep, Zably ARM64 now. So that's the easy fix. Just don't mention the architecture and we'll be fine. So let's do that fix in all of those. And that should take care of that particular problem. We're probably gonna see the image build fail just because of that shortly, but yeah, we at least have some of the fixes kind of getting ready. There's also the tests and build pipelines that will need some adjustment, but that's not, we don't need to rush that. Now in here, okay, so that's gonna need some fixing because it's for the EFI files, and you can see on AMD 64, it knows what to do, but it doesn't know for the other architectures, and we just fail with isn't currently supported. So what's the Go arch on ARM64? Is it just ARM64? I'm asking in this case because ARM is a bit weird. Well, it's not really. Like, most architectures are weird and people can't agree on naming. Debian, Ubuntu call this ARM64. The kernel calls it AArch64. The architecture type itself is some variations of ARM v8 point something. So there's like at least 3 or 4 different names for the same architecture, and not everyone uses the same in the same context. So in this case, we need to know what runtime Go Arch looks like. The easiest is actually to just test it. So if we do test.go, package main, import both format and runtime, and then we do a basic main function that just format print ln runtime Go Arch. Okay, so let's go with that. Okay, And then I need to get my path tweaked again because this is a different shell. Okay, go run test go. ARM64 is the answer. Okay. And you see that above it just blew up. So I'm just gonna fix that one and we can try building again. So ARM64, and then we need to know what the normal patterns for the different files is. We can see here it's boot x64, x64, x64. It's not gonna be x64 on ARM. The good thing is that I'm in an ARM VM running EFI, so I can just go and look at what it looks like. And we see that the answer is AA64. So every time x64 is normally used, we use AA64 instead. So that x becomes AA, this becomes AA, and this capital X becomes capital level A, like that. And with that, I think we technically fixed everything, or at least everything we could find at this stage. Like those have not been tweaked yet, but this one has. The other hard-coded stuff is gone. The build failure here is happening because what are we trying to install? Not actually sure what's going on here. I mean, it's trying to install a bunch of AMD64 stuff, so that's clearly wrong. But I'm not sure why. Is it because of a dependency? Like, it's pulling a bunch of AMD64 right from there. Get repo. I'm trying to see if it's because it's trying to install the kernel or Incus or something, which is one of the things we fixed. Or if it's because macOS just tries to do AMD64 out of the box and fails. It might be that. Let me just go check the docs for macOS, or its man page anyways. Because there is, obviously there's the case where we've hard-coded AMD64, and then there's cases for like other tools that hard-coded AMD64. And in this situation, I'm guessing it might be macOS actually having the architecture hard-coded somehow. So I'm not seeing any mention of that in their documentation, so I don't know. Let's look for architecture. Do we have any file in there? Oh yeah, there we go. x86-64. That's fun. Okay, so do we have more of those to deal with? We do. Sweet. Okay. So architecture. It's one of those cases where like I'm not sure that we need that. It says the architecture to build the image for. Notes this currently only works for architecture compatible with the host architecture. Sure. Is it required? I don't know that it is, so let's try removing it. And then try building again. The other ones need to be taken care of still, but let's see if that gets us further. Because like the least hard coding and templating and stuff we need to do, the better. So if we can just remove architecture names and it just picks the one of the local system, then that's great for us. So let's see, maybe we'll get lucky. Given they don't have a default value for that key, I think it will either work or it's just gonna tell us that it's required. So far, it looks like it's working. Anyway, that one can keep running, and then down there, I'm gonna go and look at the other x86-64 since we just found a few of those. Again, I'm gonna ignore the GitHub stuff for now. I don't really care about the publisher either, so we can ignore that. This probably just needs tweaking to not be architecture specific, but it's just a comment, so it doesn't matter too much. We can just do something like this to make it less specific. But there's going to be some issues with these two effectively needing some fixing. So let's check. And part of the issue here is that I don't actually know what some of those, like, it used x86-64 initially. This was the architecture that was listed. Now I have no idea what it will actually generate this time around. So we kind of need to see one build happen to see what the artifacts look like, to then update the code and, kind of do that back and forth. So anyway, this is, looks like we're going quite a bit further. So I think it's actually building with the right architecture this time. Let's see in here, in the x86 64 stuff. Okay, so that's the partition codes with their name per the gdisk output. So we're gonna need to duplicate all of those. I need to kind of go see if I can find the values ahead of time. Otherwise, we need to just generate an image to get the values out and then update this. So if I check for because like there's a hard-coded table somewhere I remember finding on the internet that gives us all the values in one shot. So I'm kind of hoping for that. That'd be convenient. User variety. Okay, this guy. IE64. Yes, another. Okay, what code are we looking at? We're looking at 8385. Yeah, that's not listed in the thing I'm looking at. Oh, but 8319 probably is. Yeah. Okay, so 831B is the equivalent of 8319. I think we can do extra spacing to make this a bit more slightly easier to read. There we go. So equivalent of 19 is, we said 1B. Equivalent of 14 is, what's 14 in my table here? 16 is the equivalent for ARM. But I've no idea for the 8385, so I need to actually check that one. User variety signature 8385. Yeah, that's not really helping. I mean, we're going a lot further because we're actually building the ZFS kernel module now. So we'll have an image soon enough that I can then inspect to get that stuff out. Because Google is not being very helpful as far as providing me a table. Oh, actually, never mind. I just found one. Okay, so 8385 is Linux x86-64 user variety signature. Okay, cool. We agree on the name. And then the equivalent ARM64 for user variety signature is 8375. Not sure why it's earlier, but sure. Okay. And its name is basically this. So Linux ARM64 user variety. I'm just gonna check the other one. So 831B we said. 831B is Linux ARM64 user variety. Okay. So I basically found a table. Not sure who extracted that, but that gives us the values. We'll need to first build something just to test it. And that's the last one of those. Okay. All right, so that's that file done. Now, if we grep for more, so yeah, we've got this guy. We still need to figure out. I'm not sure. So this one is one of those where I really don't know what the architecture name is going to end up being now. My guess would be ARM64. That would line up with the GPT spec, but the GPT spec has it in all caps. So I don't know if it's actually going to be -user ARM64 all caps, or it would have been brought to lowercase and just be ARM64. We might have to wait for that image to finish building. One of the downsides here of building on ARM64 is that even though this is an ARM64 server with 48 cores and reasonably fast, it's not anywhere near as fast as any of my Intel based stuff, like any of the AMD servers I'm using. So we're going to be waiting a little while for, in this case, ZFS to build. But it's looking pretty good, because if we get that far, we're really not far away from having an image. I don't think it would be a functional image, but it would be an image. Let's check if it already generated any artifacts. Yeah, no, it didn't really. That would have given us the answer for what the file name is gonna be. Yeah, at this point we basically need to wait for ZFS to finish building. The rest of the image build is usually fast enough. Just wondering if we could make it faster by giving it a bit more CPU. Yeah, it's burning through all the CPU right now. Okay. I mean, can try it. Config set Incus OS build limits CPU, and let's be very generous and give it 16 CPUs. Okay. I guess ARM64 does not support CPU hot plug then? That's unfortunate. Because on Intel that works, well, on x86 that works fine. Oh well, was worth a shot. Yeah, still waiting for this stuff to build. Actually, you can see, you know, I mentioned the ARM architecture name being kind of all over the place, and there's a good example here. So you can see it's building, the architecture folder is ARM64. The compiler architecture is ARM v8.5-A. Is there any AR64 in there as well? That wouldn't surprise me, but I didn't see one. Not seen any AR64. But yeah, there's basically 3 names for the same thing. Which, yeah. Oh, actually, never mind. There is an AR64 right there. So you can see, like, in the same build command in case for ZFS, we literally have all those 3 different names for the exact same architecture. So that's why we never really know what to expect as far as artifacts name on ARM64 machines. And not that ARM32 was any better, like it had a whole bunch of different names as well, with different endianness and a bunch of different things. So anyway, it makes things interesting. Okay, so it looks like the base image must have been built, I guess, because we're building now a layer with Incus itself installed. So that's usually the image layer. All right, so it did just generate some artifacts. Let's see if they showed up on disk yet. Incus OS, make OSI output. Kinda, they're there, but it's not giving me the final file name, so it doesn't really help me yet. Okay. How about now? Nope, still not. What we can do now is confirm. I think if I do the base, that's a folder. Incus.rar maybe. Yeah, so it gives us some hints around the naming. It will most likely be ARM64 lowercase. And we can see it uses some of those types we've seen before. We were looking at the ones for the user partition. Those are slightly different codes because they're for the root partition instead. Given that, I'm pretty sure the answer is gonna be if we look at here, so that's x86-64. I'm reasonably sure it's gonna be ARM64. Okay, so what's the actual condition? It checks for the .dfi file, otherwise it's the user file. If strings contains whatever user dash architecture dot. Okay. I'll probably just turn it into a double else if and do this. Okay, so those we've ignored. The tools we've been ignoring, so all of those been ignored. And those all have equivalents, so we're good. The question saying like creating a VM Rocky 9 with an agent disk. Should I be able to restart the VM without that agent disk? Yeah, I mean, if you're using one of our images, it won't let you start the VM at all without the agent disk. So basically it will, if you try Rocky Linux 9, R9 VM, if you, like in this case, I'm not passing an agent disk, so it's gonna immediately fail with, you need an agent disk to start it. Because we want to provide a good, consistent user experience, we require that it's present. But if you install it manually, then you'll be able to start it. You just won't be able to do incus exec or incus file, but you'll be able to stop and restart the VM. You'll be able to use its VGA console. You can SSH into it if you've got SSH set up. But as it stands, yeah, if you try to use the image from our image server, it will want you to add the agent disk, which is do it that, oops, typo, do it that way, and then you can start it. Okay, anyway, we finished building the image, so let's go look at the artifacts. And yeah, user ARM64 lowercase. So that lines up with what I was saying. And that gives us a kind of our normal output with a raw image. Okay, basically chances of that working in a useful way, not super high, because I built it before I did the other changes. Now with the other changes, pretty good chance it will function, or at least get a bit further. But I don't really have time to rebuild it in this stream, so what I'll just do is just try it, basically see what that looks like. One weirdness with ARM is that most ARM platforms are not capable of nested virtualization. That includes the server I'm in. So I can't actually start the VM directly from there. I'm gonna need to kind of go through some hoops to make that work. So I'm actually gonna go directly on the server. Just makes my life a bit easier here. And then I can switch to the actual project. So it's this. Now I'm effectively on the same server and can see the instances directly. Do I have anything? Just clean things up a bit. So let's pull from that image, from the VM, we're gonna pull the actual disk image. So Incus OS, and then we want the dot raw, this one, and download. Oops, make OS I output, forgot. Okay. So it's gonna download those 3 gigs. And then I should be able to attach that, like effectively grow it to 50 gigs, attach it as the primary boot drive, and then start a VM from it. It's kind of the old school way that we were doing at the beginning of IncusOS deployment before we added all of the test scripts and everything. But the test scripts assume that the machine that's building the image is capable of running it, which we're not dealing with here. So I'm gonna go do that. Also, I could have built it as an ISO and then imported it as a proper ISO in Incus instead of going around Incus like I'm doing now. But I forgot to do that, so I'm just gonna be using the raw image instead. And I just want to see if it does the key enrollment, if it boots, you know, just kind of the basics. Okay, so first thing first, we need to grow that image. So we need to grow it to 50 gigs is the minimum we require. So let's do 60 just to be safe. Okay, now that image is 60 gigs large. And then create a new VM, so Incus OS test on this machine. We'll just give it 4 CPUs, 4 gigs of RAM, disable the default secure boot keys, It's an empty VM. And that's usually a good starting point, I think. Then we need to add a TPM. And then the actual Incus OS drive, which will be used as a boot drive, not as an install media in this situation. Not sure why it's not auto-completing, but sure. Okay, boot priority 10. Okay, and ARM is a bit annoying in that we can't easily do the text console. So we need to we actually start it here with Incus OS test console VGA. Okay, that failed to start. Now why? TPM CRB not a valid device model. Sweet. Okay. Well, that's gonna be some debugging I need to do separately then. I've not tried a VTPM on ARM in a little while, so apparently something changed in either QEMU or SWTPM that will need a small fix to Incus itself to properly handle a TPM, at which point we can actually run the test. So I'm gonna have to leave it there because that is not gonna be a super quick fix. I mean, the fix itself is probably a one-line change, but getting there and rebuilding Incus and rolling it out on that machine and stuff, that's not gonna be super quick fix. So yeah, if we just go back to how things are, I effectively got things building just fine, and I've got some basic changes. Actually, this change is wrong. I just noticed. Let me go fix it. I'm adding a return when there shouldn't be one. Like, oh, no, actually, it might be fine. Might just be the diff that's confusing. Let me look at that again. Oh yeah, it's just a diff being confusing. Like this line already existed, but it doesn't count it as new, and instead this line is counted as new. So just the diff being kind of backwards. That's fine. Okay, so we're adding support for the new GPT partition signatures, adding support for the new UEFI artifact names, adding support here for the file paths when handling updates, just avoiding hard coding architecture names in a comment here and then dropping the architecture name from everywhere else, which then seems to be doing the job as far as building things for whatever is the local architecture. So the build seems fine. Actually, one thing I can try just for kicks, we can remove the TPM. That should still get us booted partway through, and then it's gonna fail because of the TPM requirement, but we can at least try that, just see if the rest, what's the state of the rest of the boot. Okay, so no TPM this time. Okay, so UEFI firmware, doing enrollment, so that worked. That's the normal first boot behavior. And then we can pick it back up. We're booting Incus OS in 3 seconds. That's good. And no display output. It might be we don't have the right display drivers in the initRD. No, we do. Okay, we're fine now. Incus OS is starting. Incus OSD is showing up. And unable to begin install without seed configuration. I mean, we didn't ask for install, so I'm not sure why it's doing that. That being said, it also is not matching the TPM requirement, so it might have failed because of that. Oh yeah, it's most likely what happened actually. On boot, it would have done the partition, it would have attempted the partitioning, which would have failed due to the lack of TPM, which then makes it fall back to install mode. Let's see. Yeah, bingo. Systemd repart failed to run. And if we look at why, systemd repart failed to run due to lack of TPM. There we go. So yeah, that makes sense. I think we should handle that case slightly better. I'm gonna give another note to Matthias on that one. instead of just going into the installer and then failing because there's no install seed, we should actually figure out that, okay, we're hitting the installer because we were not meant to install, but we couldn't boot due to lack of TPM, and we should show one of our hardware requirements model messages in Incus OS, basically saying, hey, your system is missing a TPM, you can't move forward. But yeah, otherwise it's good. We've got an image, it actually boots, it does the secure boot enrollment just fine. Everything else seems fine, except obviously for this blowing up due to lack of TPM, which is totally expected. Do we have curl? We have curl. Okay. I'm just gonna go check if I can poke at the Incus OS API. I don't know if it's actually running that early on. Yeah, no, it's not. Okay. Would have been nice to just poke the socket and see if the rest of the secure boot detection and everything looks good. But given the early error, we don't really have any of that. Yeah, it just shows that it immediately failed, and that's it. Okay, well, I'll get to at least send those changes upstream because I think they're all looking good. Need to figure out what's going on with TPMs on ARM64 so that I can do an actual test of the image after that. And once everything looks good, we're gonna start publishing them as well on the image server. That will probably need a few more tweaks because we've got some other things consuming that API that currently don't filter based on the architecture. So that will need to happen. And then I'm gonna have to try and get that on actual hardware, which is gonna take a bit more effort to get going. But yeah, hopefully this was a useful live stream. Like, as usual, an update of where we stand on Incus OS. You get to see some of the behind the scenes of the demo server and some of the weirdness that we've had on that front. And then also, looking at building on a different architecture, looking at some of the behind the scenes of how things work on modern ARM64 platforms, and running into a few issues here and there and kind of going through those. So hopefully this was an interesting live stream. If you've got any questions, you can feel free to leave them down below. You can go on the community forum. As I mentioned in the release announcement video from last week, we're also trying to use the chat feature a bit more on the forum. So if you want to chat, we're trying to use that more than IRC, just kind of a bit of an experiment. The built-in chat in the forum has proper threading, better history and that kind of stuff. So we're trying to see if that would be a viable platform for us. Our initial plan was to go full on Matrix, but given the number of issues that other communities have been running into and trying to use Matrix as their chat platform, I'm a bit reluctant to spend a lot of resources and time into making the switch to then potentially end up with a bad solution for our users. The built-in chat in the forum is very convenient for us to use, so we're just giving that another shot, see if it can't work for us. Anyways, enough rambling. Hopefully it was an interesting stream. I should be back next week with something else. Until then, see you later. Bye.